All right, so we have that the amount in milligrams of a medicinal drug in the body T hours after it was injected is given by dt equals blah blah blah. See, before this injection, the amount of drug in the body was 0. For part 1AI, we need to write the initial dose of the drug. Now, there's a couple of keywords going around here. First of all, for T hours, it's after it was injected. See? And the keyword for part 1, part A, part I is initial dose of the drug. So initial makes us think of like the beginning, right? And so the initial dose of the drug is going to be as early as we can in our function. How is the earliest we can go in our function? Well, t has to be greater than or equal to 0. So that is 0, 1, 2, 3. I cannot go negatively in this case, ¿cierto? These negative values are not included because we are only looking at t greater than or equal to 0. So that being said, the lowest I can go is 0, right? So I'm going to plug in d with t equals 0 like this. Now notice, anything to the power of 0 is going to be 1. So this actually turns into 23 times 1. So 23 times 1 is going to equal simply 23. See, so the initial dose of the drug is 23 what? Milligrams. So that is part 1, part A, part I. For part 1, part A, part double I, we have the percentage of the drug that leaves the body each hour. Okay, so here it gets a little bit more creative, right? So our function looks a little bit like this. And here it's more about being familiar with like how these functions work in the first place. See? And so what is affecting my initial dose, which is 23, ¿cierto? This 23 here. What is affecting my initial dose is this 0.85 right there, ¿cierto? And so 0.85 is taking away how much from 23? That is kind of like the question we're trying to answer. That is the most intuitive way I can put it, ¿cierto? And so what a lot of people do here is that they say, okay, the percentage of the drug that leaves the body each hour is the number right next to 23, so it's 85%. See? Now, there's a way to check this, ¿cierto? This is a mistake, and there's a very intuitive way to figure it out. So if 85% is what leaves each hour, after 1 hour, I should have very little dose left, ¿cierto? So let's see if that's actually true. We take this 23, we multiply it by 0.85, and we put it to the power of 1, ¿cierto? Because 1 hour has passed. Now, if effectively 85% leaves after 1 hour, I should end up with a really small number. However, I end up with a very big number. I end up with 19.55. So there's no way that I'm losing 85% per hour, ¿cierto? So actually what's going on here is that this 0.85 is taking away 15%. See? The best way I can explain it is that you should do 1 minus 0.85, and this is how much is being taken away, 0.15. 0.15 turned into a percent, multiplying by 100, ¿cierto? Will give you 15%. See? So that is like the intuitive way of understanding these functions. Now finally, we need to calculate for part B, ¿cierto? The amount of drug remaining in the body 10 hours after the injection. So the only trap here that they might throw at us is that this hours here isn't the same as this t here, ¿cierto? However, for this problem, this t here is equal to the amount of hours there, ¿cierto? So they're all hours, is what I'm trying to say. Sometimes the AB has it in days, other times in hours. They ask it in hours, they give it in days, and you're gonna have an eye for that, ¿cierto? In this case, we're all good to simply plug in. So for part 1b, we will simply plug in d10, ¿cierto? So our t is going to be equal to 10. We have 23 times 0.85 to the power of 10, right? And so that will give me, give me a second, that gives you 4.52811. See? Don't forget your units, we put milligrams. If you want to simplify it a little bit, you would leave it as 4.53 milligrams. Both answers work. So that is number 1. All right, so for number 2, we have an inclined railway travels along a straight track on a steep hill as shown in the diagram. We have the locations of the stations on the railway, which can be described by coordinates in reference to x, y, and z axis, where x and y are in the horizontal plane, ¿cierto? So this guy and this guy, these are the horizontal plane, and the z axis is in the vertical, which is this guy here, straight up, ¿cierto? Vertical, straight up. All right, so that is my current scenario. They also tell us that the ground level station A has coordinates blah blah blah, which is the same blah blah blah, which is right here, and the coordinates of B are the same up here, ¿cierto? It's always worth checking that stuff, making sure a diagram has all the information that we need. All coordinates are given in meters. Those are units. Let's include it in our answer. So for part 2, part A, we have find the distance between stations A and B. So what is the keyword here? What is the keyword here? Distance, ¿cierto? Anytime you hear the word distance, or even if you're not sure what to do, just open up your formula booklet, see what you can find. Once you identify the buzzwords, it should be relatively easy. So in our formula booklet, we have a distance formula, which is right here. See? So you just gotta trust the process and use it and see where you end up. ¿Cierto? I'll explain in a moment how it works, but I'm just saying this is a tool you can use. You have this the day of the exam, so use it. ¿Cierto? Getting familiar with the formula booklet is very important. So the formula I conveniently have it written down here. See? Now I'm sure some of you are wondering, okay, well what the heck is x1? What is y1? What is z1? Blah blah blah. See? Essentially, um, what I'm writing right now is one set of points. What I'm writing right now is another set of points. See? And so the x1, notice the 1, ¿cierto? Has to go with another y that has a 1, with another z that has a 1. An x2 has to go with a y2 with a z2. It is illegal. It is completely illegal to have something like this. This does not exist because these are 3 separate points and you're using different coordinates for each and it just don't work. See? So this is like the key stuff I'm trying to explain. ¿Cierto? Ones go with ones, twos go with twos. And so your mission right now is to find x1, y1, and z1 that goes together, and an x2, y2, and z2 that go together. So you define which is your first point, and you define which is your second point. Just because I choose to do it this way, I'm going to say that this is my first point, right? And so I will call 140 my x1, 15 my y1, and 0 my z1. Then for the other point, I'm going to call 20 my x2, 5 my y2, and 250 my z2. ¿Cierto? Just take a moment, do this step so that you use the formula like as you should, ¿cierto? So that you don't mess it up. So I'm going to plug in, this stuff down here and see where we end up, ¿cierto? So D is going to equal square root of x1, we said it was 140, minus x2, we said it was 20, squared, plus y1, ¿cierto? 15, minus y2, 5, squared, plus 0 minus 250 squared. See? So we put all of that into our calculator and we will end up with something that looks a little bit like this. 277 meters. Let's not forget the units. So that is for part A. See? All right, awesome. Then they tell us that station M is to be built halfway between stations A and B, and to find the coordinates of station M. So once again, ladies and gentlemen, what is the buzzword? The buzzword is halfway. A mitad de camino, mi compadre. So halfway between stations A and B. So somewhere along this white line, maybe like there, let's call it, is going to be my point M, and it's going to be exactly halfway. That means that this distance here is equal to this distance here. See? All right, awesome. So buzzword, halfway, midway, midpoint. Aha, we open up our formula booklet. Midpoint, where is this bad boy? I can't write it. It's right below it, ¿cierto? So that is the equation we will be using. See? I already identified what x1 and x2 is, y1, y2, z1, z2. So I'm just going to plug in. Should be pretty straightforward. See? Yeah, cool. So having that equation in mind, we will have x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2, comma, z1 plus z2 divided by 2. See? And so this will end up giving me 160 divided by 2, 20 divided by 2, 250 divided by 2, And this will be something like part 2 part B gives me 80 comma 10 comma 125. See, so that is the equation we use. That is part B. For part C, we need to write down the height of station M in meters above the ground. See, and so part C is relatively easy. The tough part is like identifying how to read this set of points, ¿cierto? Because I know that reading a set of points of X, Y, and Z can be seriously confusing, ¿cierto? So what we're used to reading, so I'm going to start with that. What we're used to reading is X and Y, ¿cierto? And so we're very used to saying, okay, X is my horizontal, see? And Y is my vertical. This is what we are used to, right? And so it's something like this, see? That is what we're used to looking at. And so a lot of people in this part are going to say, okay, so the height is going to be my Y because it's what it's always been. And they're just going to say the answer for part 2C is going to be 10. Therefore, this 10 here. That is a mistake. That is a mistake because when you're working with 3D, you now know that X and Y is going to be your horizontal. And your vertical is now going to be C. ¿Cierto? So that's like the kind of thing you have to watch out for. For part 2C, it's just going to be this 125 right here. ¿Cierto? If you have 125 meters, ¿cierto? Don't forget the units. If you have a little bit of trouble remembering that, because it is a detail, ¿cierto? Hey, you can always read the problem, ¿cierto? In this problem here, they tell you z-axis is vertical. And even if the problem doesn't tell you that, they should write somewhere down that C is the one that goes straight up, ¿cierto? So there's a couple ways to remember that, right? Anyways, that is number 2. All right, so for number 3, we have a storage container consists of a box with length 90 centimeters, width 42 centimeters, and height 34 centimeters. See? They also tell us that it has a lid in the shape of a half cylinder as shown in the diagram. The lid fits the top of the box exactly. And that the total exterior surface of this storage container is to be painted and to find the area to be painted. So, if the total exterior of the storage container is to be painted, then we're talking about the surface area. See, my biggest like hint for surface area is think about picking up your shape, dumping it in chocolate, taking it out, and seeing what is covered in chocolate in the end. ¿Cierto? And so the first step we have to take is take a moment, imagine that, and see what sides of my shape are being covered. ¿Cierto? And that is the area that we will have to find. So we don't have to find the area of like say this rectangle and this rectangle and this one and this, like you don't have to find the area of absolutely everything, ¿cierto? And so you really have to take a moment and think about what areas do I need, which ones do I not. See? For example, I think it's easier to say which ones do you not need. You do not need this one there because it's not going to get hit by the chocolate. And that's it, quite literally, ¿cierto? So we need every single shape except for the one that I just, drew an X on. See? So there's a couple simple ones. Let's start with those. We will go for, let's say, this guy here, ¿cierto? So this guy here, we are talking about a rectangle. So we know that it's 42 times something. So that something is this height here. This height here is the same as this height here, which is 34. ¿Cierto? So we have 42 times 34. And we take a moment and notice that because it's a box, then that square here is the same. That rectangle there is the same as that rectangle there. So we have 42 times 34 twice, right? All right, cool. What about the other side, ¿cierto? Let's finish up with the box. So we have this guy here. So I'm talking about that rectangle there, ¿cierto? What are the parameters of that guy? Well, we know that this 90 here is the same as that 90 there, ¿cierto? So it's going to be 90 times the height, ¿cierto? We already saw that the height is 34. See? Once again, ladies and gentlemen, you're probably catching on to it. This happens twice. ¿Cierto? It happens with this rectangle there and this rectangle over on this end. See? All right. Now we're going to talk about the one that's like flat on the bottom. I'll use another color because it's getting a little complicated. So I'm talking about that rectangle here. ¿Cierto? So what are the parameters of that guy? It's much more straightforward. We're talking about this 42 times 90, ¿cierto? The ones that are already highlighted there, 42 and 90. And this is where a lot of people say, or they, tunnel vision and they say 2. Why is it not 2? Take a moment. Why is it not 2? Because, as I said earlier, if I dump this guy in chocolate, what does not get painted, Tony? Tony, this does not get painted. See? This does not get painted, so instead of 2 rectangles, in this case, we are talking about 1. See? I know it's a little bit unnecessary to put this 1 here, because 1 times 42 times 90 is like nothing's going to change. But intuitively, I would leave it. See? It's easier to think about it if you just kind of leave it. See? So that is in respects to the box. Now we are talking about the cylinder. Now the cylinder gets a little bit more, it gets more juicy, ¿cierto? So first of all, almost no one knows the formula area for a cylinder by memory, and so let's pull it up, see? So the area of a cylinder is here, see? So the area of a curved surface of a cylinder is A equals 2 pi r h, see? So I'm going to talk about that in a moment, but I got it from the formula booklet, see? Know that your formula booklet has all of this stuff. So surface area curved side, ¿cierto? Cylinder is A equals 2 pi RH. So let's go with this guy first. See? Since we're talking about the curved surface area of a cylinder, notice the keyword curved. See? So curved is going to be, well, all of the part that's curved, right? So it does not, ladies and gentlemen, it does not include this circle here or that circle over there. We are only talking about the curved part. See? So having that in mind, well, what is the radius? What is the height? ¿Cierto? So the radius, easier one to see probably, is in respects to this circle here. ¿Cierto? So this radius, we're talking about that guy there. ¿Cierto? Now that guy there, ¿cierto? This line that I just drew is equal to that guy there, is equal to that guy there, because this is all the same radius, is equal to that guy there. Ooh la la. All right, there's something going on there. ¿Cierto? So this radius that I just drew here looks pretty convenient, right? Why is it convenient? Well, because this 42 here, I can cut it in 2, and that's going to give me that value there. ¿Cierto? Let's remember that what I'm looking at is this whole thing is 42. ¿Cierto? So if I want to find just the radius here, I'm going to take 42 divided by 2, 21. So my radius is going to be 21. See? All right, cool. So the radius of my cylinder is 21. So I have 2 pi times 21 times, oops, I forgot the 1, times 21 times h. So I still need h, ¿cierto? What the heck is h in this case? Well, a cylinder, ¿cierto, is usually going to look something like this, see? And so the height is very easy to understand in that sense. It's just this guy here. The thing is, this cylinder is kind of like on its side, ¿cierto? And so the height is actually going to be what we would think of as the length, ¿cierto? And so that is what's going on here. The height is like, like our cylinder fell over and now it looks like this, see? So the height is going to be what goes alongside it, which is this 90 here, because this 90, I can pull it up. It's this 90 is the same as that 90 down there, see? So my height, all of that I just explained to say that my height is 90. So I'm going to plug in 90 over here, see? All right, some of you are probably thinking this guy got it wrong. If you did, good job. If you didn't, take a moment and tell me why would this be wrong? Why would this be wrong? This is wrong because this surface, blah, 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 because my formula for the surface area of the curved side of a cylinder is for a whole cylinder, ¿cierto? Ladies and gentlemen, here we are dealing with a half cylinder. And so I gotta take this bad boy, this formula right here, divided by 2 to find the surface area of half a cylinder. So if I take this guy divided by 2, this goes away with this. I end up with just pi 21 times 90. See? And so this right here, which I will draw in, let's say, green, ¿cierto? Is the surface that we're talking about there, right? The only thing I'm missing are my 2 circles. All right, so now we have to do the area of a circle, ¿cierto? And so we pull up the formula booklet, the area of a circle is highlighted right there. ¿Cierto? So A equals pi times r squared. See where r is the radius. So area circle, right, we said was pi r squared. So we mentioned way earlier that our r was 21. ¿Cierto? So I'm going to have plus pi times 21 squared. See? Now this is one circle. ¿Cierto? Notice that we have two circles. See? So I'm going to make sure that I have a 2 over here, right? Because we're talking about two circles. But same as before, we are talking about half a circle. ¿Cierto? Because it's a half cylinder, we also have half a circle. So this is actually divided by 2. See? You can put this into your calculator and it works just as it is. But knowing fractions, this 2 goes away with this 2 and we end up with just that. ¿Cierto? Anyways, you plug all of this into your calculator and you end up with the value of 2,100 centimeters squared. Ladies and gentlemen, that is how you do number 3. Don't forget the units. This is squared because we're talking about area. If it were volume, it would be cubed. And if it's distance, it is to the power of 1. Just like these guys here, they are all to the power of 1. We don't write it down because it's not necessary. See? But yeah, that is number 3. All right, so for number 4, we have the diagram below shows a helicopter hovering at point H, 380 meters vertically above a lake. See? Point A is the point on the surface of the lake directly below the helicopter, so this is a perfectly vertical line. Minta, which is right here, is swimming at a constant rate in the direction of point A, which is that way. Minta observes the helicopter from point C as she looks upward at an angle of 25 degrees. See? After 25 minutes, Minta is at point B and she now observes at a degree of 40. See? So for part A, we need to write down the angle of depression from H to C. What the heck is the angle of depression? See? So the angle of depression is going to be at your very tippy top. So from H, ¿cierto? So at this tippy top here, you draw a horizontal line. And so this horizontal line, your angle of depression, is in respect to the point you're trying to find, ¿cierto? And so if my point is C, ¿cierto? I'm going to draw lines from my angle of depression, from my tippy top point until I reach point C, ¿cierto? So once I reach point C, this right here is going to be my angle of depression, right? And so how can we find that? Well, there's a little bit of a hint here. Your angle of depression is the same thing as your angle of elevation. See? And so your angle of elevation is the same idea, just that the other way around. ¿Cierto? So you make a horizontal line from point C. How do I reach point H? Well, I draw lines, ¿cierto? Until I reach point H from point C. It's the same line that I drew earlier. If this guy is 25, then this guy is also 25. See? So your angle of depression is always equal to your angle of elevation. That is quite literally a law for part 4, part A, ¿cierto? We're just going to say 25 degrees, and that is good enough. If you're still not convinced, you can look into the properties of parallel lines, which is something like this. If you have two parallel lines and, another one cutting through them, this guy is equal to this guy, which is equal to this guy, which is equal to this guy, and this other guy in red is equal to all the ones in red. See? And so that is a parallel lines property. You can look into it. The other hint you can use is that angle of depression equals angle of elevation. See, so that are two ways that you can approach part 4, part A. Both work. That is part A. See, for part B, we need to find the distance from A to C. So what we need to find is this whole guy in red. See, that whole distance there. Now, as you may have noticed already, we've got a couple of triangles going on. So I'm going to take a moment, erase this parallel line stuff down here that we don't need anymore, and draw the triangle we're talking about. So from A to C, ¿cierto? We have this. We know the height, which is 380, ¿cierto? We know that this guy appears our point H. And we know that right here we have 25 degrees. We know one more thing. We know one more thing that can help us quite a bit. We know that this guy here is drawn straight vertically up. So this is the 90 degrees, ¿cierto? We also know that this guy here is 25 degrees, which helps us discover that our missing angle, ¿cierto? This guy here in yellow is going to be 90 minus 25, right? So 90 minus 25 will give me 65. See? So this guy here is actually 65. All right, so this is a triangle we're working on. There are a lot of ways to approach this for finding the distance from A to C, which I will call x. What I always suggest is using the sine rule. ¿Cierto? So the sine rule, you may have seen it a couple of times. You have distance on top and angle on the bottom. ¿Cierto? So side divided by sine angle equals another side divided by its respective angle. See? All right, so how does this work? It works in pairs. This 380 is paired to what? This 380 is paired to that angle there. So I can immediately say, all right, 380 divided by sine 25. So that is one pair that I'm talking about. The other pair that we want to find is this x right here. ¿Cierto? They're asking for AC. I'm calling x AC, so I'm just going to put x right there. What is this x paired to? It's paired to this 65 degrees right there. So I'm going to have it like this. Ta-da! Not that bad, eh? So now I need to get x alone. I cross multiply. If I cross multiply, I end up with x times sine 25 equals 380 times sine 65. See? I want to get x alone, so I divide both sides by sine 28. This goes away with this. X equals 380 times sine 65 divided by sine 28. See? I plug everything into my calculator, just how it looks right there. And this gives me just about 814.912. See? If you want to round it up or whatever, you can leave it as 815. Don't forget the units. What were the units in this problem? We know that this is 380 meters, so this has to be meters as well. See? That is for the distance from A to C. Now we need to find the distance from B to C. All right, so using our diagram as much as we can, we plug in the information that we have found already. So we know that this guy here is 65 degrees, ¿cierto? And we know that this guy in red is 850 meters. ¿Cierto? So that is information that we have right now. And we need to find the distance from B to C. Now I can think long and hard, and eventually you're going to conclude that there's no like super mega direct way to find the distance from B to C. ¿Cierto? And so when you encounter these kind of scenarios, well, you just kind of have to like find sides, find angles until you get to B and C. ¿Cierto? So try to, what I'm saying is that like fill in your diagram in as much as you can until some flippant way you're going to find BC. ¿Cierto? Why do I say this? Because it's very hard to visualize like the steps to get to BC. ¿Cierto? You can say, oh, if I get this side, then I can somehow get BC, which is true, ¿cierto? Because you know 815. Or you can say, oh, if I get this side, I can somehow get this other side because I have the sine rule, which is also true, but it's also very hard to teach. It's hard to teach that kind of like visualization aspect. So what I'd rather suggest is get as much information as you can, and you're gonna figure it out on your own. And that's also a way that you can train, the steps. Like that's the best way you can try to start visualizing. See, get as much information as you can. You're gonna see which information was useful and which wasn't. See, and so just to conserve time a little bit, it's pretty useful to find AB. ¿Cierto? As I said earlier, if you find AB, you can just do 815 minus AB equals BC. ¿Cierto? Which is exactly the distance we're trying to find. Finding AB is not terribly hard, but you do have to get pretty darn creative for it. ¿Cierto? And so if we're talking about AB, we are talking about this triangle here. ¿Cierto? We are talking about H, A, and B. ¿Cierto? What do we know about this triangle? We know that this is 90. We know that this is 40. So this last guy here has to be 50, right? We know that H and A is 380. That's pretty much all we know. ¿Cierto? And so what is the way that I can get A to B? Well, you have to apply a little bit SOHCAHTOA. ¿Cierto? So SOHCAHTOA, I'm sure you've heard of it, makes reference to sine, cosine, and tangent. See? So since we know all of these angles, we have to play around with that. ¿Cierto? we also have to plan around the fact that we have this distance here, ¿cierto? And so for our TOA, our tangent, the tangent of 40, its opposite is 380, its adjacent is AB, which is exactly what we're trying to find. So what does this translate to? Using TOA, we have that the tangent of angle 40 is going to be opposite 380 divided by adjacent AB. Let's get AB alone. So AB to the other side by multiplying equals 380 divided by tan 40. ¿Cierto? So what I did here was multiply by AB to both sides and divide by tan 40 to both sides. ¿Cierto? We end up with this. So AB equals whatever that is, which is just about 453 meters. See? So that is for AB. All right, so for finding BC, as we said earlier, we just kind of like subtract, right? So for part 4C, oops, I kind of ran out of space. I'll do it up here. We're just going to take 815 subtracted by 453, and that will give me BC. ¿Cierto? So BC has to be just about 362 meters. All right, cool. So that is part 4C. For part D, we need to find Menta's speed in meters per hour. All right, you got to be careful here, particularly with units. That is what the AB tries to catch you with anyways, most of the time. So, the scenario is the following. After 15 minutes, as the problem told us way in its description, we know that after 15 minutes, Minta is at point B, ¿cierto? So, Minta traveled from C to B in 15 minutes. And so what was her speed there? Well, what was the distance she traveled? We found that BC was 362 meters. So she does 362 meters, right? I'm just going to do it over here, maybe. She does 362 meters per 15 minutes. So instead of per 15 minutes, we need it in per hour. And so how do I turn 15 minutes into 1 hour? Well, 15 minutes, 30 minutes, 45 minutes, 60 minutes. 60 minutes is 1 hour. This happens 4 times, ¿cierto? So it's times 4, right? So if I multiply both of these guys times 4, ¿cierto? You end up with 1,450 meters per 1 hour. See? Ta-da! That is part D for number 4. All right, so for number 5, we have the number of sick days taken by each employee in a company during a year, and it was recorded. The data is organized into a box and whisker diagram as shown below, this guy right there. So for part A, the entirety of part A, they ask us for minimum, lower quartile, and median in terms of sick days. So part A is really asking you, like, do you know how to read a box and whisker diagram? And so a very intuitively, or like quick review of a box and whisker diagram is that this first stick here is going to be your minimum. This guy here is going to be Q1. This guy here is going to be Q2, and this guy here is going to be Q3, and of course this guy here is going to be my maximum, ¿cierto? Let's remember that my Q2 is the same as my median, so whatever cuts through the middle here is going to be my median. Bada bim bada boom. So that's minimum, Q1, Q2, Q3, and maximum. Let's also remember that since that from the minimum to Q1, ¿cierto? This guy here is going to be 25% of my data. From Q1 to Q2 is another 25%. And from Q2 to Q3 is another 25%. And from Q3 to maximum is my remaining 25%. See, so that is like a representation of percentages in terms of Q1, Q2, and all that stuff. Yapo. So for part 5, part A, part I, we need the minimum number of sick days taken during the year. We said that the minimum is the first guy shown here, ¿cierto? And so let's try to find out how much that value is. If this is 5 and this is 0, then it has to be proportional, right? So you take a moment, you count the squares, you see if it works or not. You're going to find out that every 2 squares is 1 unit, and so this is 4, this is 3, this is 2, this is 1, and of course we have 0, ¿cierto? So this guy here is going to be 2 days. For the lower quartile, lower is going to make reference to Q1. The higher quartile is going to make reference to Q3. A lot of people mistake this saying higher quartile is Q2 because it's right after Q1. That is a mistake. Let's remember that Q2 is defined as my median, ¿cierto? Which they actually ask us for it later down the road. So let's find Q1, ¿cierto? If this guy here is 5, then this guy here is 6, and this guy here is lined up with my Q1. So this guy here, the part double I, ¿cierto? Part double I is going to be 6 days. Finally, for the median, it's right at Q2. We know that this has to be 7, and of course this has to be 8. See? So Q2, or median, same thing, has to be 8 days. All right, that is the entirety of part A. If I went a little too fast, I have other videos that go a little bit slower. You can check them out. Later we have Paulie. My guy Paulie claims that this box and whisker diagram can be used to infer that the percentage of employees who took fewer than 6 days, so fewer than 6 days is from here to here, ¿cierto? Because that is where my 6 is smaller than the percentage of employees who took more than 11 sick days. So 11, where is 11? All right, we know where 6 is, and so 6 is from Q1 until, well, minimum, ¿cierto? Let's see where 11 is. And so if we keep going counting these numbers, if here we have 8, here we have 9, here we have 10, here we have 11. What's going on over here? So this 11 is lined up with Q3. So Q3 to over there is going to be maximum, ¿cierto? And so what Polly is telling me is that this, like this here is less days than this here. That is what Polly is trying to tell you. And so what a lot of people would think here is, okay, the line on the left is clearly smaller than the line on the right. Polly is right, ¿cierto? But hey, this is where, you know, like the intuition of a box and whisker diagram kind of like kicks in. Let's remember that we were talking about percentages earlier, ¿cierto? And so from, as I said way back then, a minimum to Q1 is 25%. Q1 to Q2 is 25%. Q2 to Q3 is 25%. Q3 to the maximum is also 25%. And so actually the amount of sick days in both of these ends, ¿cierto, is equal to each other. The amount of days is equal. What is not equal, and why they're drawn differently, is that from minimum to Q1, they are much more concentrated, right? And so there's like a lot, for example, ¿cierto? There's a lot of people that called in for 2, 3, or 4 sick days, ¿cierto? It's like, it's very concentrated. A lot of 2s, a lot of 3s, a lot of 4s. But over here, there's much more spread. Some people called in 10, others called for, say, 17. And so, boom, there's a lot more spread. The way I draw it is much bigger than my other one, ¿cierto? And so the fact that there is a big distance here is really talking about my spread of my data in that area, ¿cierto? In that part of my data, in the upper percentiles from 75 percentile to the 100th percentile. The spread down here is much lower, see? But that does not mean that there are less sick days. One thing is spread, another thing is amount. The amount is the same because they are both 25%. Aha, interesting. And so we would say that, hey, Polly, sorry, homie, but you're kind of wrong. You are wrong because both min to Q1 and Q3 to max are 25%. See? That is one way to answer. There's a couple ways, but I think that's the most intuitive one. That is part 5, part B, and the whole exercise, actually. So for number 6, we have that two schools are represented by the points 2,20, which is this guy here, and 14,24, which is this guy here. Then they tell us that we have a road represented by the line R with the equation of negative x plus y equals 4. See? And we have then an architect is asked to determine the location of a new bus stop on the road such that it is the same distance from the two schools. So there is some point along this line where this distance and this distance is the same, or this and this is the same, or this is the same. See? So that is our mission. It's pretty intimidating. Let's go step by step, see what the problem asks. So for part A, find the equation of the perpendicular bisector of AB. Give your equation in the form of y equals mx plus c. So, first things first, what the heck is a perpendicular bisector? So, the familiar word, or probably more familiar word, is the word perpendicular. See? So let's remember that perpendicular looks something like this. Perpendicular to r would be that. Perpendicular to x-axis would be that. Perpendicular to y-axis would be that. ¿Cierto? Perpendicular to, I don't know, this line is that. So what's special about it? Well, a couple of things. But what I want you to keep in mind for now is that the slope of perpendicular lines is this. The slope of my first one times the slope of my second one has to equal -1. See? So in a certain way, you can actually say that the slope of one is going to be, you multiply negatively and you flip it. See? So that is kind of like the intuition, or so to say. This is the mathy way to like remember it. There's a couple intuitive ways to remember it. Whatever. See, whatever floats your boat. But this is what the fact of that it's perpendicular, that's what it tells us. See? So if it's perpendicular, that's what it's telling us. That's how the slopes interact. The fact that it's a bisector is a little bit different. See? And so in its name, bi is for two, cierto sector. We're going to be cutting it up into sectors. And so the bisector of R would be something like this, cierto? A line like that, where this distance here is the same as this distance here. See? The bisector of my x-axis right now would be something along this line, where 0 to 12 is equal to 12 to 24. See? So that is the intuition of a bisector. So we're talking about the bisector of AB. So let's take a moment. Let's draw the line AB, which goes something like that. So the bisector of AB, you're probably already imagining it, is going to be something like that. See? Okay, so this distance would be the same as that distance. Now, why is it important that it's perpendicular? Well, first of all, it's useful information. But second of all, you could, in theory, ¿cierto?, have a bisector that goes like that. It looks much more weird, but it still completes the property that, hey, this distance is the same as that distance. See? This is still a bisector. It's not a perpendicular bisector. Perpendicular bisector probably looks something like that. See? So that is my current scenario. We need to find that line. We need to create that line. How do you create lines in this world? So for creating lines in this world, there's a couple equations we can use. See? And so if you open up your formula booklet, you're actually going to find a couple. For equation of a straight line, we have these three guys here. See? And so just so that we're all on the same page, we need it in this form there. See? We need it in the form of y equals mx plus c, because that is what the problem is asking for. ¿Cierto? Now, I'm going to give you a tip. See? Always, 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 always. It might take a couple extra steps, pero always, always go with the point slope form, which is this last guy here. See? This last guy, all you need, literally all you need is the slope, which is m, and a set of points, which is the x1, y1, which we're seeing there and there. See? So if you have just the slope and just a set of points, boom, you can create this. And now, I know you may be thinking, okay, but I need it in this form here. Why don't I just use that form? Well, because it's hard to use that form right away. What's always going to work is what I'm trying to say. What's always going to work is that you do the point slope form and you jump from here to here, or you jump from here to here. All you got to do is move some terms around and you're going to get to those forms without a problem. See? And so we have to find the slope and the set of points in order to make this work. Let's go with the slope first. ¿Cierto? And so slope is equal to gradient. So slope equals gradient. And the formula for that is right there. ¿Cierto? So y2 minus y1 divided by x2 minus x1. All right. So slope of AB, ¿cierto?, is y2 minus y1 divided by x2 minus x1. See? Now, as I said earlier, x1, y1 makes reference to set of points. See? If you have x1, y2, this does not work. See? It does not work because it's not consistent. Notice that I'm being consistent with one here, ¿cierto? So my point A is going to be my first point because I chose it to be that way. X1 will be 2, y1 will be 20. X2 will be 14, y2 would be 24. If you wanted to, you could flip this around. Like dead ass. You can say that this is x2 and this is y2, or that this is x1 and that this is y1. What you cannot do is have x1 with y2 or x2 with y1. See, that is where things get illegal and stuff does not work out. See? So again, just be consistent. You define it whichever way you want. Anyways, we're coming back to what I mentioned earlier, x1, y1, x2 is 14, y2 is 24. See? So having that in mind, I'm going to plug it in. We end up with 20 minus 24. Oops, I already messed it up. 24 minus 20 divided by 14 minus 2. See? So this will give me 4 divided by 12, which is the same as 1/3. So this is the slope of AB. See? Now we know that this is perpendicular, right? And so the slope we're trying to find is the perpendicular to the slope of 1/3. See? So using this property here, we actually have 1/3 times m2, which is the slope of my guy in red. Cierto? This guy red here. Equals equals -1. See? And so I multiply times 3 to both sides in order to get m2 alone. I end up with m2 being equal to -3. See? So this m2 makes reference to the slope of my red guy. Got it? So right now we have the slope we were asking for. See? So slope red guy is -3. What we need now is a set of points, ¿cierto? So once we have a set of points, we can use the point slope formula that I was talking about earlier, because it's the only two things we need. We already have the slope. Now we need this, the set of points. See? So how can we find the set of points here? Well, we know that we are dealing with a bisector, ¿cierto? And so we know that this perpendicular bisector is cutting right through the middle of AB. Right through the middle. So we are talking about a midpoint. To the Batmobile. What is the midpoint formula? Right there, ladies and gentlemen. Right there. So this is the one we're going to be using now. This is all your formula booklet. Get familiar with it. Identify the buzzwords. It is very useful. So, midpoint formula. I'm kind of running out of space here, but I'll figure it out. So, midpoint is going to be x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. See? So we said that x1 was 2, ¿cierto? So we have 2 plus x2, we said it was 14, divided by 2, comma, y1 was 20, and y2 was 24. See? So we have 20 plus 24, divided by 2. So we work this out a little bit, we end up with 16 divided by 2, comma, 44 divided by 2. We develop this a little bit more, and our midpoint is going to be 8, comma, 22. So this is my big point M. 8, 22. We're talking about this point here is 8, 22. So why did we do that? Again, just so that we can use this guy over here in my formula booklet, as I showed you earlier, equations of a line. See? So now that we have the slope, now that we have a set of points, we can plug into the point slope formula. The point slope formula we said was y minus y1 equals m times x minus x1. See? So my x1 is this, my x1 is this guy, my y1 is this guy. See? So, y minus y1 equals slope -3 times x minus 8. See? Slope is -3 because it's what we identified all the way back here. Slope of the red guy, which we got from this here, which came from this, which came from that. Cool. So, y minus 22 equals -3x, because I multiplied -3 times x, plus 24, because we have -3 times -8. I want to get y alone. Why do I want to get y alone? Because this here is y equals mx plus c. And so we know that we have to get y alone, and everything else will just kind of like float into place. So I'm going to do plus 22 to both sides. See what happens. Y equals -3x plus 46. Ladies and gentlemen, that is the equation of the red line. This is the equation of my perpendicular bisector. See? So again, follow the process. Go for the point slope formula. I'm telling you, this guy will be your savior multiple times. See? So that is for part A. Part B tells us to determine the coordinates of the point on R where the bus stop should be located. All right, so the point. So because this is the perpendicular bisector, the guy in red, wherever that lands here is going to be equal distance from the both schools, ¿cierto? Why? Because the kids will drop off here, walk the same distance, and walk the same distance again from A to B. And so that's fair, ¿cierto? It's completely fair. They are walking the same distance. In fact, this and this would also be the same distance. See? So um, wherever my perpendicular bisector touches my line R is where, oops, is where the bus stop should be created, is what I'm trying to say. See? So that is why we did part A in the first place. See? So where do these lines meet is what I'm asking for. Where do they intersect? There's a couple ways to do this, but the first thing is identifying, okay, my first line has this form here. ¿Cierto? So my first line has, I'll just do it down here, see? It's negative x plus y equals 4. See? So this is my first line. My second line is y equals negative 3x plus 46. So there's a lot of different ways that you can solve this from here. You can use your calculator, calc intersect, ¿cierto? You can also use you can just kind of like do it by hand. I'll show how to do it by hand. I think it's like a little bit quicker. But hey, there's a lot of ways to do this from here. See? The first thing is that you want these two equations to look similar, ¿cierto? So the best way is to have y equals on both of them. I have y equals on the bottom. Let's have y equals on top. So y equals on top would be like this. Y equals x plus 4. See? So all I did was add x to both sides. See? So now that I have them in a similar form, I can use a system of equations. ¿Cierto? This probably sounds familiar. System of equations, I can either substitute, I'm not writing that well at all, or eliminate. See? In this case, I think it's a little bit better to substitute because you already have y on both sides. See? So this y here is going to be plugged in there to the other y. ¿Cierto? And so if I do that, I end up with x plus 4 equals negative 3x plus 46. Okay, why is this useful? Well, before I would have two variables. ¿Cierto? I have one variable, another variable here. I could never get them alone. ¿Cierto? Instead, down here in orange, I have it all in terms of x. ¿Cierto? There's only x's going around, so I can find x equals a number. Before I could not find x equals a number, I would always have a y going around, and it was very complicated. See? So we want to get to x equals in this case. I'm going to throw everything to the left side in terms of x's. So I'm going to do plus 3x, 4x plus 4 equals 46, 4x equals 42. That happened because of minus 4. See? Let's get x alone, divide both sides by 4. We end up with x being 10.5. See? Cool. So now we need to find what y is, ¿cierto? And now that we have a value for x, getting y is actually super duper easy. I can plug in this value here into either this guy. Whoops, apparently that's not going to work. I can take this value here and plug it into this guy here, or this guy here. I get the same answer. I'm going to do it to the one on top because clearly it's way easier. And so doing that, we end up with y equals 10. Sorry, my value of x, which you said was 10.5. So 10.5 plus 4, y has to be 14.5. See? So that is my x comma y, which is the location of my bus stop for where the bus stop should be located. See? So my answer finally would be 10.5 comma 14.5. That is how you do number 6. All right, so for number 7, we have that a function is defined by f of x equals 2 minus blah, blah, blah for these x values, see? And x cannot be that. So all this thing on the right side is actually my domain, all right? Later on, for part A, they ask us to find the range of f. So because we're in the world of domain and range, let's take a moment and explain that for a second. Domain is essentially going to be your x values, see? Range, on the other hand, is going to be your y values. And so what happens is that in order to get y values, you need to plug in x values. What do I mean by this? The x values, you plug them into your f of x. This gives you a y value. See? What x values can I plug in this case? These ones here. Which one can I not plug in? Anything beyond that, and negative 5. See? So those are the ones I can't plug in. The ones I can plug in are boxed in right now in orange. See? And so that's going to spit out a bunch of y values, and that is exactly the range that we're trying to find for part A. See? And so of course you can spend a lot of time plugging in negative 7, negative 6, negative 5, negative 4, negative 3, etc. and see what happens. But there are some faster ways to figure it out. See, I think the quickest way is taking a moment, opening up your calculator, going to y equals, and plugging in here so that we can graph. See, so I'm going to plug in f of x right now. It'll look something like this: 2 minus fraction, ¿cierto? For fraction, I can do alpha y equals, hit the first one, and boom, I can plug in a fraction very easily. There's other ways, but hey, whatever floats your boat. See, since we are graphing, let's go ahead and pull up the window. See, so window here kind of like defines what my graph is going to show. Since I know that my domain goes from this to this, I'm going to put exactly that. So minimum x -7, maximum x 7. And for y for y min and y max, we can eyeball it later, see what's going on, but for now, I think this is fine. So let's graph, see what happens. Beautiful. So if we take a moment and look at this graph, I'm actually going to draw it down here because I'm going to spend some time talking about it. We can see that at -7, I have like a big value over here that goes all the way up. And at +7, it kind of reaches a maximum and it goes down. See? And so what I need to do for the range is see what y values this reaches. See? And what y values this reaches. See? And so once I define all of that, whoops, that's not very good. Once I define all of that, I will be good to go. See? Awesome. So everything in between is not my range. See? Everything right here is not my range because I'm not touching anything on my function. Everything in yellow is because it is touching something of my function. See? So that is the game plan. Let's go with the top left first. See? So this top left, we take a moment, we analyze it. We see that there's a -7 here. ¿Cierto? So I can plug in -7, and from -7 upwards, ¿cierto? Is going to be my range. Let's see what happens. So if I plug in -7 for f of x, we have 2 minus 12 divided by -7 plus 5. This gives me 2 minus 12 divided by -2. Double negative, I end up with 2 plus 6. This gives 8. See, so what that's telling me is that this point here is 8. And so my range right on -7 is telling me that, hey, when I have -6, for example, I also have a very big number. See? So I don't know what it is, but it's bigger than 8. And so my range, we can say, is going to be, give me 1 second, something like this. Greater than or equal to 8. See? This right here means your y values or your range. Another way you can write it is like this, which for me was always more intuitive. Whatever floats your boat. See? And so my y values are actually greater than or equal to 8, which makes reference to this 8 right here. How did we find that 8? By plugging in -7. How did we know to plug in -7? Because we graphed it, looked at it, and we could tell, hey, from -7, as it grows, we have growing values here as well. All right, so that is for the top left. See, let's do the bottom right for now, ¿cierto? So as I mentioned earlier, from 7 to like some point here, ¿cierto? It's like decreasing, ¿cierto? It's decreasing, and we gotta find out what's going on, ¿cierto? So what we can do is plug in the point of 7 and see what y value this gives me here. See? And so whatever y value I get there, I'm gonna say, hey, it's all these y values and the ones below it. See? It'll make sense, more sense in a second. I'm going to plug in f of 7. See? So that's going to give me this point here. And in consequence, that y value there. So f of 7 is 2 minus 12 divided by 7 plus 5. 2 minus 12 divided by 12, 1. So this point here is 7, 1, ¿cierto? Which means that this point here is also 1. And so essentially, all of these values that I have in yellow, that I will now draw again in purple, let's say, ¿cierto? All of these have a y value of 1 or less. All of these have a y value of 1 or less. In the other case, we had a bunch of y values that were 8 or more. See? So here is 8 or more. Here is 1 or less. Ladies and gentlemen, this is for part A. So you can leave it like this. If you want to get very fancy, you would leave it in the other form that looks like that. See? But honestly, this explains the same information. This is your range of your function. See? So that is for part A. For part B, we need to find the value of that. See? And so what the heck is that? That makes reference to the inverse function evaluated at 0. See? So let's start first by getting the inverse function. I have more space down here, so I'm just going to do it over here. We know that f of x is 2 minus 12 divided by x plus 5. See? So if we need to find the inverse function, the best way that I can explain it is that your x and y are flipped. See? And so to find your x and y, to find the inverse function, the most intuitive way, I think, is saying, okay, I'm going to plug in y for this. See? And now I'm going to flip my x and my y. And it'll look a little bit like this. I will have x on this side equals 2 minus 12 divided by bada bim bada boom y plus 5. So notice that my x and y were flipped. See? After I flip them, I want to get y alone. Once I get y alone, that will be my inverse function. See? Once I have that inverse function, I will plug in 0 and I will be done with the problem. So anyways, that is the most intuitive way I can explain how to get the inverse function. So I need to get y equals somehow from this position here. Because I have y on the bottom of a fraction, I want to get rid of that right away. It's super annoying. The best I can suggest is multiply everything by y plus 5. Why do I do this? You will see in a second. So I multiply this by y plus 5, this by y plus 5, and this other guy by y plus 5. The reason I do this is because this guy here goes away with that guy there. Suddenly, my variable is not on a fraction anymore. It's much easier to deal with. See? So if I write it out real quick, we can see that this is much more friendly than what we had before. See, we don't like our variables in denominators. So now I'm going to distribute. I distribute on this side. I end up with xy plus 5x equals, distribute again, 2y plus 10 minus 12. See? Now I want to get all my y's on one side, so I'm going to throw them all to the left. I have xy minus 2y, which comes from this guy here. And I throw this 5x to the other side, so I end up with negative 2 minus 5x. See? Negative 2 because I combined these two. I end up with negative 2. Now, since I have all my y's on one side, which is exactly what I wanted, I need to factor. So it's useful to factor because it allows me to further get y alone. So y parentheses x minus 2 equals negative 2, negative 5x. See? Now I can divide both sides by x minus 2, end up with something like this. Negative 2 minus 5x divided by x minus 2. Why do I divide by x minus 2? Well, it's what I factored by. It allows me to get rid of these two. I end up with y equals something. ¿Cierto? This was our big goal, getting to y equals something. That something is this. And this right here, ladies and gentlemen, is my inverse function. See? This right here is my inverse function. And so since we need to evaluate our inverse function at 0, I just plug in 0 for x. So negative 2 minus 5 times 0 divided by 0 minus 2. This ends up being negative 2 divided by negative 2, which gives you positive 1 because of the double negative. That is part B of number 7. Alright, so for number 8, we have that at Springfield University, the weights in kilograms of 10 chinchilla rabbits and 10 sable rabbits were recorded. The aim, important that the aim was to find out whether chinchilla rabbits are generally heavier than sable rabbits, and the results obtained are summarized in the following table that is, well, it's right there. See? So a t-test, keyword t-test, is performed at the 5% significance level. So everything I put in yellow is what is important here. Those are the buzzwords. For part A, we need to write down the null and alternative hypotheses. So the intuition, okay, for null and alternative hypothesis is, well, first of all, HO is null, see? And your HO is usually going to be the not version of your H1. See? So your HO is going to be your not version of your H1. HO is null. H1 is alternative. Okay? And so what the heck is your H1? Your H1, your alternative hypothesis, tends to be what you're trying to find out. What you're trying to find out. Look at that. So what I'm trying to find out in this case is whether chinchilla rabbits are generally heavier than sable rabbits. So in fancy math language, I'd say something like mean weight chinchilla has to be greater than a mean weight rabbit. See? And so that would mean by H1, the not version of that would be that the mean weights are just like equal. See? Now, just to be a little more consistent with how this tends to show up, the mean weight of the chinchilla, we are going to call it UC. The U is for like the mean sign, ¿cierto? And the mean weight of the rabbit, we will call it UR. See? And so my H1, I can actually write it as UC is greater than UR. And my HO is going to be that UC is equal to UR. See? So that is for part A for my null hypothesis and my alternative hypothesis. Now moving on for part B, we need to find the p-value for this test. So first things first, we open up our trusty rusty calculator here, ¿cierto? And what we're gonna do is go to stat, because we are looking at a statistics problem. Go to edit and put all of our data here. See? And so I already did this beforehand, but essentially this guy here is going to be L1 and this guy here is going to be L2. See? So L1 is chinchilla. Let's not forget what we're doing here. And L2 is going to be rabbit. See? So now we have our stuff here. And they asked us, or we are told, that this is done with a t-test. See? Buzzword that I highlighted earlier. So my t-test, if I go again to stat, go over to tests, I have t-test here on the second one. See? However, if I click here, I notice that I only have one list. See? I have list L1. And right now I have two lists, right? So that is a big hint that I need to go to the two sample t-test. How do you know that it's a two sample t-test? Well, because I have two lists right here, and intuitively I'd say you're dealing with rabbits. Sorry, you're dealing with chinchillas and sables. So that makes two different populations. That's gonna make it a two sample t-test. See? So you put L1, L2. Here on this row, it's asking like for the hypotheses. See? So here you actually want to put like the alternative hypotheses. It's like depending on these three signs that you pick, it's either doing U1 does not equal U2, U1 is greater than U2, or U1 is less than U2. See? And so we need to not forget our north. In our scenario, L1 in our calculator is chinchilla, ¿cierto? And here we're saying that chinchilla has a greater mean. And so if I open up over here, the version where U1 is greater than U2 is this last one here. See? Awesome. Last but not least, we go to the pooled section. And so pooled makes reference to if the lists are taking data from the same population. See? And so although they are both being taken from rabbits, they are not being taken from the same type of rabbit. See? So in this case, we're going to put pooled yes, because they are separate populations. See? Go ahead and calculate. These are the values that we get. And so for part B, that's literally all you have to do. See? Part B, you put it all into your calculator and you say that your p-value is 0.0408. See? If you're worried about showing your process, you literally have to say this is L1, this is L2, stat test two sample t-test. See? So if you write that out, that counts as showing your work. See? Anyways, that is for part B. Now for part C, they ask us to find or write down the conclusion to the test and give a reason for the answer. This, unfortunately, is one of those things that you just kind of have to memorize. But if you do it enough times, it'll enter your brain. So that is a good sign here. What we need to compare and when we reach the state of concluding a test, is the p-value and the significance level. So my p-value, we got it for part B, it's here. See? 0.0408. And the significance level is 5%. See? So what is 5% in decimal? 0.05. Remember that 1 is 100%. See? If you remember that 1 is 100% and that 0.5 is 50%, you should be able to figure out the rest very intuitively. 0.05 is 5%. See? Anyways, the case is that my p-value is less than my significance level. And whenever that happens, we reject H0. All right? I suggest that you always look at it from the perspective of H0, just because you have to memorize it and might as well do it one way or another. Another way you can think about it is that this means that we accept H1. See? But in practice, we always talk about rejecting or accepting H0 specifically. But hey, whatever floats your boat. See? So what you gotta do is memorize this, that if whenever your p-value is less than your significance level, you reject the HO. If I want to get really, really fancy with it, I would say that 0.0408 is less than 0.05. That makes me reject. See? Reject HO. Anyways, that is number 8. I hope it helped. All right, for number 9, we have that a garden includes a small lawn. The lawn is enclosed by an arc AB of a circle with center O and radius 6 meters, such that angle AOB is 135 degrees. The straight border of the lawn is defined by chord AB. That's this guy here. See? So the lawn is shown as the shaded region in the following diagram. All right. So a footpath for part A, ¿cierto? Is laid around the curved side of the lawn. So that makes reference to this guy here. So that right there is where we have the footpath, and we need to find the length of that guy exactly. Now at this point, a lot of people start thinking, okay, I've got a triangle here. They're trying to remember stuff about circles, and they have a little bit of a rough time. See? A good strategy here, as you've seen in some of my other videos, is identify the buzzwords. See? And so the buzzword right now, the biggest one is length. Find the length of the footpath. The footpath is part of what? It's part of a circle. Ah, okay. So if you get familiar with your formula booklet, this should be ringing a bell by now. If I go ahead and put length, there's a couple lengths that show up, ¿cierto? And one of them is length of an arc. See, so if we're talking about circles, we're talking about arcs, we're talking about sectors and stuff like that. And this formula right here is going to give you the length of the footpath. See? And so the two big steps that we did was 1, identify the buzzword, and 2, be familiar with your formula booklet. See? No one memorizes all of this stuff, but it's very important to know what's in it. See? So length of an arc is, I'm just going to put it aside here, but you know that I'm getting it from the formula booklet. It is L equals theta divided by 360 times 2 pi r. See? All right, so the stuff that we have to figure out is theta and r. See? So theta makes reference to what parts of the arc we're looking at. Since we're looking at this part of the arc, the respective angle is right there, 135. See? So that is how we get the 135. And the r, they told us way, way earlier that we have a radius of 6. See? So that is how we get radius. Remember that pi is an actual number. It is in your calculator. So yeah, that's what we have to do. We plug this in to our calculator and we get a value of, trust me on this one, 14.1371, which is pretty much 14.1 meters. See? So that is literally part A. Got it? So this distance in red is equal to 14.1 meters. See? Now we need to find the area of the lawn. See? And so we don't have a formula that is for the area of just this. See? What we do have a formula for is the area of this whole guy here. ¿Vale? And so we've employed that formula and then subtract this guy here, we end up with the area of the lawn, which is the shaded part. See? So that is the strategy that we're going to employ. We return to our formula booklet, and we have area of a sector. See? And so arc and sector in this case are kind of similar. Your sector, if I'm not mistaken, so your sector is going to be this cohort guy here. ¿Vale? Your arc is what we put in red earlier. So for part B, area of a sector, I'm gonna use this formula here. I'm gonna put it on the side, but you know that I'm getting it from the formula booklet. It is theta divided by 360 times pi r squared. See, and so if I plug everything in, much like earlier, we know that theta is 135, pi stays as pi, and r we said was 6. See? So this right now is what I put in blue earlier. See, it's all of this. It's all of this. What we want to do now, whoops, what we want to do now is get the area of this triangle here and subtract it. See? So we're going to be subtracting by whatever that is. And so we're looking at this triangle there. See? Now, what do we know about that triangle there? We know the following. We know that we have the point A, O, B. We know that this is 6, and this is 135. See? So now we're in the land of trigonometry and stuff like that. See? And so there's a couple ways to try to get the other sides, the missing angles, etc. But again, if you're familiar with the formula booklet, we can go to area of a triangle. And there's two of them. See? We have the one where it's the classic base times height divided by 2. And the other one, which is the trigonometry version. See? Where we have 1/2 AB sine C. See? So area is going to be 1/2 a little b times sine C. Why do I say big and little? Well, because the little letters are going to be sides. See? So these two guys are sides. And this guy is the angle. See? Now, because the angle C, because we have big C and not little c, see, because we have big C and not little c, that means that the angle I have, or that I need, ¿cierto? I need the sides that are right next to it, see? Because if this is big C, little c is right there, see? Anyways, that being said, I can employ this formula and end up with 1/2 6 times 6, so that's A and B. I'm just going to call this A, I'm going to call this B, whatever, times sine C, which we said was 135. Got it? So that is actually going to go over here. All right, just so that we don't get lost, I'm going to take a second and leave very clear that if I call this guy my first area, it makes reference to literally everything. See? If I call this my second guy, that's going to be just this part here. So just this triangle here is going to be my second guy. I subtract both, I end up with my third one, the area of the lawn, the guy that's shaded. I put all of this into my calculator. Trust me on this one. And you end up with just about 29.6835, which is pretty much the same as 29.7. See? Meters squared. Don't forget your units. It is part of the mark scheme. Why don't you know that it's squared? Because squared is going to be for area. To the power of 1 is going to be for distance. And if it is cubed, is going to be for volume. See? This case, we're talking about area. It is squared. That is number 9. Get familiar with your formula booklet. And for number 10, we have that Tommaso and Pietro each have been given 1,500 euro to save for college. They tell us that Pietro invests his money in an account that pays nominal annual interest rate of 2.75%, compounded half yearly. See? Calculate the amount Pietro will have in his account after 5 years. Give your answer correct to 2 decimal places. So, whenever you see a problem like this and you highlight the same buzzwords that I did, ¿cierto? You're going to realize that you are dealing with a compound interest problem, ¿cierto? The biggest hint is that it literally says compounded half yearly in this case. See? So whenever you face a problem that is like this, you're going to pick up your formula booklet, go to compound interest, which is right there. I spelled that wrong. Compound interest. And you're going to run into this formula here. See? And so just so you know, this is where I'm getting it from. It is in your formula booklet. You do not have to memorize it. This formula is asking for 5 different things. It is asking for FV, future value, PV, present value, R, which is going to be your actual interest rate, like the percent, K, which is the amount of periods per year. We're going to talk about that in a second, and N, which is the amount of years. See? And so you will always have 4 out of 5. ¿Vale? That means you can solve the equation. See? And so in this case, they are asking us in part A to calculate the amount Pietro will have in his account after 5 years. So if it's after 5 years, we're talking about an amount that's going to come later. That means that our future value is exactly what we're trying to find. So FV is going to be X. It is going to be our whatever variable thing we're trying to find. See? Present value, how much money he puts in the beginning. They were given 1,500 euros. See? R is going to be in percent. It's already in percent. They tell us that it's 2.75. I just leave it like that. See? All right, cool beans. K. K is the weirdest one. I'll talk about it in a second. Let's first go with N. N we said was the amount of years. They tell us that it's after 5 years, so N is going to be 5. See? K is the weirdest one. K is the amount of periods per year. What the hell do I mean by this? Some interest rates work monthly. And so monthly, like money gets added onto your account, ¿cierto? And in that case, if it's monthly, K would be 12. See? And so I'm going to start explaining it through that. If it's monthly, K is going to be 12. If it's yearly, K is going to be 1. See? If it's every 3 months, that means if it's every 3 months that I have 4 periods. See? Interesting. So if it's every 3 months, I would put a 4 here. ¿Vale? If in the problem, ¿cierto? Now we are going to go to the problem. If they tell us it's half yearly, that means that every half a year, I get like a period, ¿cierto? And so how many halves to make a whole? 2 of them, ¿cierto? And so twice during the year, I get money. See? And so that is like the setup for part A. If I plug everything into, the formula, right? We're gonna have that FV equals 1,500 times 1 plus 2.75 divided by 2 times 100, close parentheses, exponent 2 times 5. And so I plug everything into my calculator. FV is going to be just about 1719.49. I'm not done yet for part A. What am I missing? I am missing my units. So it's 1,719.49 euros. See? Units is part of the mark scheme. A good way to remember is that if it's worth 3 points, 1 point is probably the unit. See? So careful with that. Anyways, that's part A. See? For part B, we have that Tommaso wants to invest his money in an account such that his investment will increase to 1.5 times the initial amount in 5 years. Assume the account pays a nominal annual interest rate of R% compounded quarterly. Ooh la la, quarterly. So now it got a little bit more interesting. See? So again, we do have to look at the 5 things and see which we're missing. See? Well, actually, for part A, they tell us to determine the value of R. See, so R is going to be the one that we're missing. All right. So we're going to do the same exact process. We're going to need to find FV, PV, R, K, and N. R is what we don't have. R is going to be our X. See? Our present value is still going to be the same. We are still have the same amount of 1,500 money to start with. N is still going to be 5 years. See? K, they tell us that it's compounded quarterly. See? So if it's by quarters, it is going to be how many quarters? 4. See? And for the FV, they tell us that They want that his investment to increase 1.5 times the initial amount. See? So I take 1,500 for the FV, ¿cierto? Multiply by 1.5, and that's going to be my FV. See? If I go ahead and do that, I get 2,250. See? So what I did just now was apply what they told us here, the thing of 1.5 times the initial amount. See? So 1.5 times the initial amount is literally what I put in red here. See? 1.5 times the initial amount, 1,500. Anyways, that is the current scenario. If I plug everything into the formula, it's going to look a little bit like this. We will have FV was 2,000, blah, blah, blah. PV was this. 1 plus X, because we don't know what R is. It's, give me 1 second, 4 times 100, exponent 4 times 5. See? And so this is how we have it set up. See? Now, a lot of people, when they reach this scenario, they're like, how the hell do I get X alone? That is the biggest challenge right now, getting X alone. See, and this is something that shows up a lot in compound interest problems. For part A, everyone's happy because one of the variables is like easy to get alone, ¿cierto? Usually your future value. But when it's not your future value, it's a little bit of a challenge to figure out what to do. So I actually have a video on this for using calc intersect, but the point is, you don't have to get it alone. All you can do is call this y1, call this y2, do calc intersect, and wherever they intersect is what makes this whole thing true, ¿cierto? Which is your x value that makes these two things equal each other. Now I know this probably sounds a little weird. You can watch my video and it has a lot more in depth to it, but essentially y1 is going to be this, y2 is going to be that. See? So when I do calc intersect, I'm going to find the x value that makes all of this true, and it will be my answer. Again, in the other video, I talk a lot about like why this makes sense, but the quick intuition, you already heard it. See? So now the annoying part that comes through is actually making the window work. See, because a lot of times you graph it and your window just doesn't show it. See? Something that sometimes works, not always, is going to zoom. Zoom 0, zoom fit. This sometimes works, not always. Let's see if it works. All we need is for the two lines to intersect so that we can actually do calc intersect. Zoom fit seems to have worked, ladies and gentlemen. And so if here I go to second trace, hit that calc button, go to intersect, I pick my first curve, which is up here, second curve, which is down there, which is really first line, second line, and I guess near the point of intersect that I want to discover, which is only that one, I get this, ¿cierto? And so I get the set of points 8.19206, comma, 2250. See? And so how do you interpret this? Well, your y value, ¿cierto? Is the same as this guy here. See? And so your x value is going to be this guy here. Dale? The point is, if you set it up like this, that this is my first line, this is my second line, wherever they intersect, your x value must have made it true. ¿Cierto? Must have made what true? This equals sign. See? And so, that being said, R has to be 8.19. See? Which I took it from there. So that is for part B. Oh, and for showing your work, you literally can set it up like this. I did it in the actual IB exam and it worked. See? I got full credit. You write everything out. You signal which one is y1, which is y2. You announce that you do calc intersect. And bada bing, bada boom. You get the answer. Eso. That is for number 10. All right, so for number 11, we have that a newspaper vendor in Singapore is trying to predict how many copies of the Straits Times they will sell. The vendor forms a model to predict the number of copies sold each weekday, and according to this model, they expect keyword here, expect the same number of copies will be sold each day. Expect what? The same number of copies will be sold each day. To test the model, they record the number of copies sold each day during a particular week. The data is shown in the table. So this is like the actual data that was gathered. See, this is not what is expected. It is the actual data. They tell us that a goodness of fit test at the 5% significance level is used on this data to determine whether vendor's model is suitable, that the critical value is blah, that H0 and H1 is blah and blah. See? All right, so a couple of important things before we jump into the problem. First of all, they give us significance level and they give us a critical value. See, and so that is useful stuff that we need in order to conclude for our tests. Second of all, H0 and H1 is in words and does not really have to do with means. See, it does not have to do with means, so we are straying away from the t-test. T-test is usually for means, and they actually tell us that we are dealing with a goodness of fit test, which is this chi-squared GOF on your calculator. See, so goodness of fit test, chi-squared GOF. Got it? Yeah. And what are our expected values? Well, we expect the same number of copies will be sold each day. So part A actually has a little bit to do with that. We need to estimate how many copies the vendor expects to sell each day. And so the way that we do that is that we take the actual observed amount, which is, 74, 97, 91, 86, 112. So this is what we observed, and divide it by 5. So whatever that is going to be our expected value or expected table. We're going to put 92 here. That is what the calculator gives us. See, so that is for part A. It's an estimate because we are taking the mean of our observed values. We divide by 5 because we do have 5 days, Monday through Friday. For part B, part I, we have to write down the degrees of freedom for this test. And degrees of freedom is one of the things you just kind of have to memorize. It's not in the formula booklet, so that kind of blows. But the formula in this case, because it's a single variable, is simply n minus 1, with n being the amount of columns that we're dealing with. And so how many columns do we have? We have one column, 2, 3, 4, 5, n minus 1, 5 minus 1. That means our degrees of freedom is going to be 4. That is part B, part I. Part B, part double I is where it gets juicy. We need to write down the conclusions for this test and give a reason for our answer. So, it's very important to make a difference between observed and expected values in this case. As we've seen, this right here are our observed values, which means that our expected values is for the same numbers of copies to be sold each day. So this is going to be expected, same amount of copies. What number will that be? It will be this number here, 92, because it's the estimate that we did earlier. ¿Cierto? Awesome. Also, it's worth mentioning, something from part B needed something from part A. That is a very, very common trend. If you're not sure what to do in part B, look at what you did in part A. Many times it can help, not always. Okay? Yapo, so for concluding, we have significance level and critical value. All right, so if I go ahead and pull up my calculator, see, and I go to stat edit, see, because we are working with a statistics problem, L1 is going to be observed, L2 is going to be expected. See, so as you can see, my observed is the same values that I have on my table. My expected is the 92 that I calculated from part A. Now we go to a test, ¿cierto? And we go to chi-squared GOF test. See? Here in the GOF test, we see that observed is going to be L1, expected L2, exactly as we have it set up in our table earlier, ¿cierto? And DF stands for degrees of freedom. We know that degrees of freedom is 4. We go ahead and calculate. See? So here we get a chi-squared value and a p-value. See? So I'm going to write those down real quick. My chi-squared value, see, is 8.54. And my p-value is 0.0736. See? So what's important to notice here is which of these gets compared to critical value, which of these gets compared to significance level. See? And so your critical value, this guy here, so your critical value, which is 9.49, is what gets compared to the chi-squared value. So here we have our chi-squared with our critical value, see? Which is 9.49. I'll talk in a second how it gets compared. And the other two that gets compared is the p-value with the significance level. See? So this is the first thing that you really have to like internalize. P-value goes with significance level. Your chi-squared or t-value or any of the other stuff is going to be compared to your critical value. See? So significance level we said was 0.05 because of 5%. Got it? All right. So you can conclude from either of these points. See? So you can either draw the conclusion from here or from here. The conclusion is the same. This is how it works. If your chi-squared is greater than critical value, we reject HO. If your p-value is greater than your significance level, we will accept HO. See? Or another way you can think about it is fail to reject. HO. See? And so those are the two scenarios, ¿cierto? So if you memorize, because you kind of have to memorize it. See, one of those things you have to memorize. If you memorize these two scenarios, ¿cierto? You can conclude any sort of test. That you just have to. This is like your compass. See, if you memorize this, this is your compass. This is your guidebook. Stick to it, and you can draw the conclusions you want. With the first case, ¿cierto? I'm going to compare chi-squared to critical value. We have 8.54 is actually less than 9.49. So does this look like that? No, it's actually the opposite. And so in this case, our conclusion is going to be fail to reject. HO. See? That is with the first example here in orange. ¿Dale? If I go with the second example that we're going to do in whatever, purple, see? Actually, purple doesn't really. Let's go with blue. ¿Dale? Light blue. Our p-value we said was 0.0736. And this p-value is greater than the significance level, which is 0.05. And so here, again, does it look like that? It actually does. And so our conclusion is fail to reject. HO. As you can see, we reached the same conclusion from either angle. You can approach this problem from either side. See, so as long as you conclude that you failed to reject HO and you put these symbols here, which are very, very important, like that symbol, the greater, less than or greater than, you're good to go. See, so either of these approaches work. At the end of the day, your conclusion is that you failed to reject HO. See? Really, really try to keep in mind what goes with what in respects to chi-squared with critical value and p-value with significance level. This is unfortunately one of the few things you just kind of have to memorize. But hey, once you do, you figure them all out. So that is number 11. All right, and now for number 12, we need to consider the function f of x equals ax squared plus bx plus c, which is really just telling us that this is a parabola, ¿cierto? Or a quadratic, which is the same thing that we see in the diagram. The vertex of the graph has coordinates 0.5, comma negative 12.5. That's this guy here. The graph intersects the x-axis at the points negative 2, comma 0 and p, comma 0. See? So all of that is in our diagram. And for part A, we need to find the value of p. Now, the cool thing about quadratic functions and parabolas and all this good stuff is that they are perfectly symmetrical. And so if you go to the vertex, which is this guy here, a vertex is always either a minimum or a maximum, and you kind of like draw a line straight down the middle, the left and right are perfectly symmetrical. See? Why is that useful? It's useful because the distance from here to here is the same as the distance from here to here. The distance from here to here is the same distance as from here to here. Ah, interesting. See, it's a little bit like your face. If you draw a dotted line vertically from your nose, ¿cierto? You have one eye on the left, one on the right. Symmetry, see? Anyways, you probably know where this is going at this point. The distance from here to here is the same as the distance from here to here. So that is actually something that can help us find p. And so what is that distance that I just drew in red? Well, the numbers we can work with are negative 2, comma 0 and 0.5 comma negative 12.5. See? Since we're drawing a horizontal line, we're looking at the x values, so we need to compare negative 2 to 0.5. See? And so how many units is it from negative 2 to 0.5? Well, if we draw a number line, ¿cierto? We have negative 2, we have negative 1, 0, and 1. See? So the guys that I'm looking at is negative 2 and 0.5, which is actually not drawn in my number line. It's right there, 0.5. See? So essentially, I have to look at the distance from there to there. It is going to be, just doing a little bit of math or even visually, you're going to tell it it's 2.5. See? So this distance here is 2.5. That means that this distance here is also 2.5. That means that 0.5 plus 2.5 is going to be p. P has to be 3. That is part A. Part B, we need to find the values of A, B, and C. See? So of course this is a little bit more intimidating, but essentially we need to find all the values of my parabola. See? So here, what we can do, ¿cierto? And what you will always do when you're trying to find a parabola and they give you some points is the following. You're going to make a system of equations. See? So a system of equations, maybe some buzzwords that you might hear are substitution, elimination, etc. Point is, you know this point exists and that this point exists, see? Which is 3, 0, right? You know that this point exists as well. So if you plug everything into all of that, into the quadratic function, ¿cierto? I'm going to plug in the first one here, see? We end up with 0 equals a times negative 2 squared plus b times negative 2 plus c, ¿cierto? So that's going to give me 0 equals 4a minus 2b plus c, right? If I plug this one in here, we're going to end up with 0 equals, I'm going to go a little bit faster now, but you know what's going on, so it's all good. 9a plus 3b plus c, ¿cierto? Awesome. If I plug into the third one here, we end up with negative 12.5 equals 0.25a plus 0.5b plus c. All right. So now, if I have 3 equations, which are highlighted here, and 3 variables I need to find, it's solvable. See? So if my number of equations is equal to the number of variables I need to find, through systems of equations, it is something that I can solve. See? And so the first thing that I'm going to do, even though it might look a little bit weird, is equal these two to each other. See? So if I equal these two to each other, I end up with 4a minus 2b plus c equals 9a plus 3b plus c. First things first, I'm going to do minus c to both sides. We're going to see that these go away. So now I end up with 4a minus 2b equals 9a plus 3b. See? Now I'm going to put all the a's to one side. So I'm going to do 4a, minus 4a, sorry, to both sides. And minus 3b to both sides. So I end up with negative 5b here and 5a on the other side. See? That means that my a, ¿cierto?, is going to equal negative b because I divide both sides by 5. See? A is going to be negative b. Awesome. So if I go ahead and do that, say, on my second equation, which I will call this one second, see, this one first, this one third. If I plug that into my second equation, I end up with 0 equals 9a minus 3a equals, So if I plug that into my second equation, I end up with negative 9b plus 3b plus c equals 0. See? If I keep working this for a little bit more, we see that c minus 6b has to equal 0. If I move some terms around, c equals negative 6b. Sorry, c equals 6b. See? All right, so why the hell were we doing this in the first place? Well, you can see that now I have A in terms of B, and I have C in terms of B. And so all of my variables can now just be expressed in B, and I'm going to do that in my first equation. See? So my first equation, I end up with 4A. Actually, no, I'm going to do that in the third equation. We'll see why in a second. So in the third equation, I have negative 12.5 equals negative 0.25 B. So I'm applying this in that scenario. Plus 0.5 B. Nothing changes there. Plus 6B. So I will be applying that there. See? And so now the magic that just occurred is that this negative 12.5 equals only one variable. It equals only B. Before, our problem is that it equaled three different variables. It equaled A, B, and C, and a bunch of stuff in between, etc. Now this negative 12.5 equals only one variable. It equals only B. So I just have to combine everything and see what happens. See? If I combine everything, I end up with 6.25B. Interesting. So I divide both sides by 6.25. B is going to be whatever that is. What is that? Let's see in our calculator. Bum, ba, bum. We have negative 12.5 divided by 6.25. Negative 2. See? So B is negative 2. Now that I have B negative 2, I can plug that literally everywhere. And so if I plug it in over here, we're going to see that A equals negative negative 2. A equals 2. If I plug it in over here for C, we're going to see that C equals 6 times negative 2. C equals negative 12. So that is how you get the A value, the B value, and the C value. Essentially, you have to play around with the system of equations in a smart way. And the smart way to do that is to put all of your variables equal to the same one. ¿Cierto? What do I mean? All your A's in terms of B. All your C's in terms of B. Once they are all in like the B way, ¿cierto? You plug it into one of them, and boom, you get an actual value. See? Why did I plug it into the third one specifically? Because the other two had an equals 0, ¿cierto? And so I would have ended up with 0 equals a bunch of B's, ¿cierto? And I can't really get an actual B value from there. The only actual B value you can get is if I plug it into the third one, because the third one has a negative 12.5 on the sides, something you can actually play with. Anyways, that is part B. See? For part C, we need to write down the equation of axis of symmetry of the graph, and there is actually a equation for that. See, it is in our formula booklet, and so if I go ahead and look it up in the formula booklet, we can see that it's negative b over 2a. See, so negative b over 2a is going to equal my axis of symmetry. See, so negative b we said was 2, ¿cierto? All of this divided by 2a, which we said was 2, ¿cierto? So 2 times 2. So we have 2 divided by 4, 1/2. See? So that is my axis of symmetry. That is part C. Now, you actually could have gotten axis of symmetry in a different way, because the axis of symmetry, we said it runs right down through the middle, and it's always going to run right through the vertex. And if you know that the vertex has an x point of 0.5, which is this guy here, that is exactly the value that your axis of symmetry is going to give you, 1/2. 0.5 is the same as 1/2. So you can actually, you could have gotten it in a different way, but the mega formal way would be using the formula. See? Anyways, that is how you solve this problem. All right, and for this last one, we actually have like an integral problem. It's a little bit complicated. We have that a company produces and sells electric cars. The company's profit P in thousands of dollars changes based on the number of cars X they produce per month. The rate of change of their profit for producing X electric cars is modeled by blah. See, the company makes a profit of $260,000 when they produce 15 electric cars. This information seems useful. We're probably going to have to use it later. For part A, we need to find an expression for P in terms of X. Now, when they say P in terms of X, that means P of X. See? This right here is not P in terms of X. That is like, well, it's the derivative, right? We're talking about rate of change, etc. So to reach P of X, you actually have to take the derivative, do the integral of that guy, and you end up with P of X. See? Why is that the case? Well, the intuition is that the integral is the opposite to the derivative. And so that's how you end up with the original one. See, it kind of like, it cancels out, you end up with the original one. See? And so we have to do the integral of our first derivative in order to get the original function. See? Now, at the IB Math Studies level, we only work with the derivative of an exponent, so I'm going to spend some time talking about that. The thing is, if I have, say, like, I don't know, 3x squared, and I do the derivative of this, I end up with 6x. How do I know? Because the step in between is 3 times 2x, 2 minus 1 on the exponent. So that's what's going on in between. This is actually in your formula booklet. The exponent multiplies whatever is in front, and the exponent gets subtracted by 1. See? That's how you end up with 6x. So having that in mind, you just kind of have to like think long and hard and go backwards. This negative 1.6, how did it appear? It appeared because I had a number that got multiplied, ¿cierto? So I'm going to call that number whatever, z. And it got multiplied by 2, which gave me negative 1.6. See? So negative 1.6 is the result of the integral. See? Z is from my original function. And 2 appears because I know that there used to be a 2 because there's an x that has a 1 here. ¿Cierto? So if in the derivative I have an x with an exponent of 1, that means that the original one had an exponent of 2. That's no different than what we have here in the example I made up. If in my derivative we have an x with an exponent of 1, that means that in my original one we had an x with an exponent of 2. It is no different. See? So that is how I know that there's a 2 here, because there's an x with a 1 there. See? Again, this is the kind of thing you have to think long and hard about. It is working backwards. It is mental work. But intuitively, that's how I can explain it. So, to find my z value, I'm going to divide by 2 to both sides. ¿Cierto? I end up with z being equal to 0.8. ¿Vale? Oh, negative 0.8. Sorry. So z equals negative 0.8. That means that in our original function, we have a negative 0.8 x squared right here. See? We're going to keep going with the other values and see what happens. See? So this 48 has no x next to it. If it has no x next to it, that means it has to be 48x. This is the same intuition that I just shared. Going a little bit more in depth, the thing is, if in my original one, ¿cierto? I have 48x, and I do the derivative, that means I have a 1 that multiplies, ¿cierto? So 1 times 48. And this 1 gets a minus 1 applied to it, so I end up with 0, ¿cierto? So it's actually 48 times x to the power of 0. Anything to the power of 0 is just 1. 48 times 1, 48. See? Now, why is x to the power of 0, 1? Well, the intuition is that, and I should actually do this elsewhere, anything to the power of 0 is 1. See? If I have 2 to the power of 1, it's 2. 2 to the power of 2 is 4. 2 to the power of 3, it's 8. See? And so math is often considered like the study of patterns. See? So what pattern arises here? Well, to go from 1 to the next, I am doing times 2. Times 2. If I go backwards, I am divided by 2. I am divided by 2. So if I divide by 2 here, 2 divided by 2, I end up with 1. See? That is why anything to the power of 0 is always going to be 1. You can see the same pattern arise with 3 squared, for example. See, so 3 squared is 9, 3 cubed is 27, 3 to the power of 1 is 3, 3 to the power of 0 has to be 1, because they divide by 3 each time. See, this is the conclusion you always reach. Anyways, that was a mini lesson on why anything to the power of 0 is 1. ¿Vale? So point is, in my original one, I have this guy and this guy, and I'm missing one more thing. See? In theory, I could have a constant here. See? I could have a constant that disappeared once I did the derivative, right? If I have, say, I don't know, x squared plus 9x plus 17, and I do the derivative of this, I end up with 2x plus 9 plus 0, and I don't write plus 0, I just leave like that. See? Constants disappear when you do a derivative. See? And so I have to put plus c here. I am obligated to. And so I am not quite done finding p of x. See, I'm not quite done finding p in terms of x because I exactly have a c going around. ¿Cierto? Fortunately, this problem gives us very valuable information for finding out what c is. What we said earlier was going to be very useful, that the company makes a profit of blah when they produce 15 cars, ¿cierto? Is applied now. So the company makes a profit of $260,000 when they produce 15 electric cars. See? So I'm going to plug in 15 for x, $260,000 for y, and work from there. ¿Cierto? And so the beautiful thing that just happened, why we did it in the first place, is that before we had two variables. ¿Cierto? We had the variable of x and c. Now we have only the variable of c and a bunch of numbers. So I moved those numbers around, find out what c is. Well, play around with your calculator. You're going to find out that c is negative 280. See? C is negative 280. I plugged it in over here for what I had before. And that is quite literally part A. All right, and now for part B, before we move on, small detail here. I did conclude that C was negative 280, but I plugged in plus. So, you know, no one's perfect. I include myself in that. Anyways, eso. See? Negative 280 for C. For part B, we have described how their profit changes if they increase production to over 30 cars per month and up to 50 cars per month, and to justify our answer that way. So from here, there's like a lot of different ways to approach this problem for concluding how their profit changes. See? So I think I'll try to give the most intuitive way to approach it. See? And that is, since we are talking about how their profit changes, ¿cierto? It's very useful to look at the rate of change. See? So rate of change, which is the derivative right here, ¿cierto? Remember that whatever this spits out the rate of change. See? So the moment that this value turns negative, that means our profit is decreasing. See? It's not necessarily that our profit is negative, it means that our profit is decreasing. See? A good example of this is, say you have like a parabola like that, ¿cierto? And you say, okay, all of these values here are the rate of changes that are here are negative, right? But they're still in the positive part of my graph, ¿cierto? Once they turn down here is where it's actually negative, see? So not because it has a negative slope or a negative rate of change means that the actual values are negative. Keep that in mind. However, that does allow us to approach how the profit changes, which is the main thing here, see? So for dp dx, ¿cierto? I'm going to plug in 30 first, right? And we end up with negative 1.6 times 30 plus 48. See? So we need to see if this is positive or negative. Work from there. We can see that negative 1.6 times 30 plus 48 actually gives you 0. See? And so right at the 30th car, ¿cierto? Sold, profit is 0. See? So profit is 0 in the case of selling 30 cars. What happens if we sell a greater number, for example, 50 cars per month? See? So again, dp dx, but for 50, we have negative 1.6 times 50 plus 48. Will it be positive or negative? Let's find out. Negative 1.6 times 50 plus 48. We can see that it's negative. See? And so this negative 32 is less than 0, which means that profit decreases. See? And so, funnily enough, even though they sell more cars, there is less profit. All right. The intuition of like real life in this scenario is that maybe they don't get to sell the cars at the same price. Maybe, you know, like they have a certain amount of buyers and they can't sell them all. Stuff like that. See? Anyways, point is, it's very evident that the more cars that they sell, profit actually decreases. See? So that is the big conclusion here. More cars sold, profit decreases. See? So they're better off selling less cars, a limited amount of cars, stuff like that. See? So that is the main way to conclude this. Other ways that you can conclude it is plugging in into here. So you're plugging here 30, here 50. And so you're not looking at the rate of change, you're looking at like the raw profit, and just compare the profits. ¿Cierto? Does it decrease? Does it not? What we compared down here was the rate of change. See? So we saw that as more cars were sold, profit is each time less and less. But what you can do up here is first see a negative trend, and second actually announce like how much profit it's getting or not. See? Anyways, all of those ways work. All of the approaches are correct. That is number 13, and that is this paper. I hope it helped. You know, eso. Have a wonderful day. Take it easy.